Thank you. Oh, good gravy. Okay. How about now?
Yeah.
Okay, I can hear that. Excellent. Cool. Hello. All right. A language for making languages for making synthesizers. That's a blatantly disorienting title, but I'll clear it up for you. To get this out of the way, I'll introduce myself, as Loris already did. My name is Stevie. It's nice to meet you. I began playing music and video games at a very young age, and I figured that a lot of you have done that too. I, after that, fell in love with music properly and started doing music production and recording and using digital synthesizers sometime around early high school. After my college days, I was lucky enough to be part of the kind of early indie game explosion and got to make a few soundtracks, which was really awesome. And I started a kind of a casual co-working meetup called Hyperclock Game Dev and Tea Time. It's actually kind of spiritually similar to what we did yesterday. It's a lot of fun, still going. At some point, I needed to pay rent, and in San Francisco, doing piano lessons and odd jobs is not enough. So I became an IT assistant at a company called Hryciw, which has since been rebranded as Fandom. And during this time, I used my spare time to teach myself programming for the first time. Yay. And then in 2016, three friends and I co-founded a company called Fleetsmith, and in 2020, it was acquired. And as of a few months ago, I decided to take a little break from the tech industry and focus on more fun stuff like this. I was briefly involved, or for a while, involved in the Zig community, and I do intend to go back to it. That's for you. Thank you, Internet Archive, the Wayback Machine. But yeah, you probably wouldn't know me through that scene, with the possible exception of this one GitHub issue. If this sends chills down your spine, you can, yeah, feel free to throw tomatoes at me or beat me up afterwards. Actually, it turns out I'm wrong. After talking to people yesterday, I had two people say, "Aren't you the guy that wrote the first recursive parser in Zig?" And I was like, "How did you know that?" Okay. Anyway, let's get down to brass tacks here. Today, I'm going to talk about a little piece of software that I've been working on and off for a while called Hryciw, which is something that can help you make your own synths and effects from scratch. But before we can just get into what that is, I need to describe the realm of digital signal processing, abbreviated as DSP. It's an acronym I'll be saying a lot, so digital signal processing. And to really, really briefly define what that is, a continuous signal, such as an audio signal, is recorded at a constant rate into discrete values. These values are numbers, and they're called samples, and this process is called sampling. Then computation is repeatedly performed to manipulate these samples or just generate new ones from scratch. You can kind of see there's like a minor difference between those two, but it's like a little filtering applied to smooth out the signal. The term DSP actually applies to way more than just audio, and in a musical context, there's like processing sensor data and sonar and radar data, and image processing, video compression, voice codecs, and a whole bunch more stuff. But today it's just about in a musical audio context. And specifically, I'm not going to focus on the sampling and recording part of this. It's just about manipulating and generating new ones. So to create kind of a context of where in the music making stack, I guess you could say, this fits, I've come up with this kind of goofy breakdown and three terms that I'll introduce for where this lives. These are not proper musical terms, with the exception of the first one, composition. And so applications that you can do composition, on the left, you can see there's a score writer, which is for music notation, Sibelius, we were just talking about that. On the right, there is a vertical tracker, kind of from the demo scene lineage of making music, and the bottom is a traditional digital audio workstation, or DAW. So if I say DAW or DAW, that's the kind of thing I'm talking about. And this is really where you create the structure of your entire piece of music. So the melody, harmony, rhythm, any pitch and timing information is really at this layer. And then below that layer is something that in a computer nerdy way, I'm calling configuration. These are some examples of VST plugins, if you've ever heard of that. That's a framework for inserting plugins into a music making system. There's a multi-band compressor on the left, there's a reverb on the right for ambience, and there's a wavetable synthesizer as an example of an instrument. And generally, this is how you choose an instrument or a sound and you tweak it to your liking. This is not creating things from scratch. This is kind of taking a predefined instrument with a predefined limited set of parameters, usually exposed with knobs and sliders, and this is how you refine the timbre of your music. And if you're like me, you wonder how those were made in the first place. And so this last layer, for lack of a better term, I'm just going to call building. And this is where you can make your own synths and effects from scratch. Obviously why, fun, one reason is for fun. Education is another reason. When you learn how these things are built, you really gain a deeper understanding of the math behind how they're made, the principles, and how the implementation is made. But also, maybe you just want to make a new sound you've never heard before, and it's not like every single music making technique has been discovered yet. There's plenty of room for exploration. So, as I mentioned, I like making games, I like making music, and at some point I was using the Love framework and writing games in Lua, and I wanted to have a particular experience to design sounds while doing so. So the desired experience that I had as a musically minded game developer or a technically minded audio person, I want to be able to design my own DSPs from code. I'm using DSP as a noun here, as a kind of stand-in for a DSP program. So I wanted to be able to do it from code, and specifically, I wanted to use the my existing language and environment. Like I mentioned, I was writing code in Lua and from a particular game framework, and I wanted to continue using that rather than going out into some other application or using a tool to pre-process something. And inside this game, I wanted to be able to procedurally control the sound from the game state or game events, like a player's position in the world can dictate the ambience, which is things, there are products that do that, like Fmod. Or maybe I wanted to totally randomly generate a new instrument, in a roguelike or something like that. And specifically, I want to focus on just the sound design part of it, rather than having to figure out how do I make this work optimally or properly. I just want a language that lets me describe the sound at a kind of high level. And I wrote kitchen sink standard library because of I want to have a good starting point with lots and lots of pre-made examples for instruments and effects that I can look at how they're made. I can iterate on them. I can build abstractions on top of them. You might wonder if there is other DSP software out there. And of course, there's plenty of them. So I'm going to try to quickly go through 4 pieces of software that I used, which didn't quite suit my needs at the time, and how they helped shape my vision for what I did want. First one I'll show is called Max MSP, and this is a visual programming environment for generative audio processing, music and audio processing. So it uses a data flow model. It's actually a totally visual programming environment. I think Unity and other game dev systems have something similar. Each of these boxes is called an object in Max MSP terminology. Other systems call them unit generators. And they have one of 2 tasks. One is to process or generate streams of blocks of audio or even video in some cases. That's those stripy yellow cables. And then the black cables represent sending synchronous messages. That's used to control the behavior of the objects or pass along events like MIDI data, MIDI notes. So out of the box, Max MSP supports a bunch of features. MIDI, like I mentioned, it can read sound files from disk and parse various formats. There's a C API, so people have made objects that do all kinds of crazy crap like networking, raw device input-output, so like Arduino integration, pretty cool stuff. And as such, I've seen Max MSP most prominently used in the education space and physical art installations and live performance, but it's also been used for pre-recorded music too. As for why it didn't quite suit my needs or why it wasn't right for my task, obviously the main point, or the first thing you notice is that it's a graphic interface. There's no headless runtime. It's not designed for that. And the whole visual programming paradigm can have some limits to expressiveness, and you can end up with I'm afraid to use the word spaghetti in a bad context, so the spaghetti police might come after me. But yeah, you get the idea. I mentioned that these objects have one of 2 tasks. And in reality, it looks like a single graph, but there are 2 graphs that kind of occupy the same physical space. And this mental model I found to be very confusing after a while. You have to keep track of what does what, and sometimes they do both, and the behavior is a little bit inconsistent. I'm not opposed to paying for software, and I don't think that commercial licenses are evil or anything like that. Obviously, I've paid for software like this before, but I think my ideal solution for what I wanted would be a free open source library. How it helped me the most, though, is I would say the user manual. I highly recommend anyone who's interested in this kind of thing, read the user manual even if you don't care about Max MSP, because it goes out of its way to teach you some fundamentals in a really, really nice way that they didn't have to do. The next one I'll show is called C Sound, and as you can kind of see, It's a language or a suite of domain-specific languages, DSLs, and a command line tool for compiling computer audio, so pre-compiling it. You can kind of see this XML structure here. There's like something labeled instruments and then something labeled score. Inside each one of those, respectively, you're defining the actual DSP work, that's the instrument. And then below that is the score, that is the sequence of notes and that pitch and timing information, so the composition layer that I first described. It also has a bunch of features, MIDI, UDP networking, I'm not sure why, image processing, which in my opinion kind of betrays the name C sound. And just before flying over here, I learned that it has a whole-ass Python interpreter built into the domain-specific language. I'm not sure what that's used for, but I might try to find out. Admirably, it's one of the oldest that I know of that is still actively maintained. It was first written in 1985, which is like before MaxMSP was even just being conceived, and they're still pushing commits to it, which is cool. As for why it was not right for me, first and foremost, it's its own domain-specific language, or multiple languages if I want to be a real dick about it, because of the XML like structure and the multiple different languages that you can see inside there. There is a C API, but it doesn't let you control that syntax tree directly. It's strictly tied to the DSL. So if you've ever like composed SQL query strings and passed that to a database, it's more analogous to, if I wanted to dynamically generate sounds, it would have to be more like that rather than like a Fluent Query Builder or ORM if you've used those things from databases. The authors of this, some of the authors of this software wrote a really great book that I'll link to at the end, which held my hand through writing my first C audio code, so I owe them a lot for that. This is a Super Collider. It's an audio processing and generative music server, so it has a server client model. And the clients compile the synths and this procedural or this generative music by issuing commands over UDP networking protocol to the server. And what I have here in the screenshot is sort of an official first-party language that's inspired by JavaScript. And there's an IDE that I'm not showing, which has online help. It's pretty cool. But there's like a whole bunch of other front ends for it. Like somebody made a Haskell front end for it, which is pretty cool. As for why it's not right for me, it's, you know, aside from this first-party language, you can use a language of your choice, but it has this inter-process communication-based model, and the server client model might not be suitable for certain types of restricted environments like mobile or something that doesn't have operating systems or the concept of threads or the concept of processes, sandbox environments where that's not allowed, and you know, some games want to target mobile, some other applications want to target embedded environments. GPL license, you know, it is a free open source license. There may be some teams of people or applications or projects that are afraid to use that. So I guess my ideal solution would probably be a more liberal license. And how it helped me the most is that after using it, this is what got me to want to make my own thing. And I don't mean that to bash Super Collider. It actually kind of inspired me to do so. The last one is called Faust. Faust is really cool. It's a purely functional language. It's the first time I've ever used a purely functional language. And it's specific to the domain of generating and processing audio. And it describes a mathematical model of the DSP rather than a literal sequence of instructions. And so it's free to optimize that, the resulting code however it wants to. There's a whole bunch of command line tools that it comes with, not just one, and each one is geared towards generating a certain kind of output. There's a lot of different targets like LLVM, so it can just generate raw machine code. It can output C source that you can just import into your project. It can make those VSTs, like those plugins that I showed you in the screenshots. It can make a Max object, so it can integrate with MaxMSP, yo dog. And then it can also generate WebAssembly, which they have like a great web-based IDE. It's pretty cool. So finally, why not Faust for me? Once more, it's its own domain-specific language, and unlike C Sound, it doesn't even have that C API. There's no C API. There is a command line tool that they have to generate a C API file, but it's really tied to one original source, Faust source, so it's not really suitable for dynamically defining these things. And in my opinion, it just does too much. You can see at the bottom there's H slider. It's because there's primitives built into the language for defining like sliders, knobs, and even their like layouts. And to me, that just steps outside of the realm where this should really be responsible. And how it helped me the most is that this purely functional paradigm was a bit enlightening for me. it made me realize that it maps really well onto the DSP domain. And so that inspired my latest approach for the design of Suzer. Yeah, so let's get to that. Earlier, let's see, so I was building these, I was working on games and figuring out what experience I want, and I started to wonder, as I was trying to build this experience, what if someday I wanted to use a different language? What if I wanted to build a different kind of application other than a game? What if somebody else wanted to do the same thing that I'm doing, make their own version? Which parts could be reusable? Mindy, you were talking about saving the trouble for other people, and that kind of thing crossed my mind too. So deeper down the rabbit hole we go. Here we go. So I became interested in not just building that experience, but building a platform that would make it easier to build that experience in general, in different ways. So here's a rough list of some design goals that I came up with over time. And remember, these are not the design goals for me, the person writing a game or designing sounds from a game, but for this platform that I wanted. Obviously, it's got to be a library, not an application, like some of the ones I showed you earlier. And it needs to be adaptable to whatever language you're using. It should be flexible to apply to bind to different languages in various ways. And an out of the box library. So a standard library full of instruments and effects. If I wanted to bind this to a whole new language, I don't want to have to re-implement that standard library in that language. I want it to just come for free, and so I can build abstractions after the fact. It should do one thing, and that's just DSP. So not only no user interface primitives, but I actually wanted to exclude MIDI and sequencing information, that kind of composition layer, and just focus on the purely sound processing part. It's got to have reliable performance, and this is a really crucial aspect of this application. The sound card, issues an interrupt to the CPU, to the system. Your operating system will invoke your high priority thread and say, I need this many samples so I can send them to the sound card. Give me that shit right now. And if you don't provide all the samples that it's asking for, then it's just going to say, peace, I'm out, and it's going to pop and click. And that's a crucial failure of this kind of system in a real-time audio context. So I am striving for a constant time runtime and making it impossible to crash one of the resulting programs. I wanted to have both ahead of time and just-in-time compilation models supported. Real quick, ahead of time compilation could be used to generate these VST plugins or something like that. But the just-in-time model I think is really interesting for quickly iterating on sound designs that you want to mess around with. I specifically wrote under 10 milliseconds as a temporal goal, as a latency goal. If two musical events happen in less than 10 milliseconds apart from each other, like two drum hits happen and they're 10 milliseconds or less apart from each other, your brain cannot register them as independent musical events. They will sound like the same note. And so this is effectively, musically speaking, instantaneous. So that's my goal for that. It's got to be cross-platform, any operating system, but ideally even embedded environments, anything that has a little bit of memory and floating point unit. Yeah, maybe the Zig embedded guys can tell me if that's realistic. And just my personal taste, I would like to have a liberal license once open sourced. I've been working in the dark on this for a while. I already mentioned games a bunch, so we can skip that. Digital audio workstations. This is not a complete music making solution, but it would be nice if this could be a drop-in replacement or a drop-in solution for the DSP engine. Andrew, you mentioned libeber 128, which I'd never heard of before, but something to take care of the amplitude detection and adjustment. This could be some kind of tool to accomplish that, maybe even in the standard library. Live music coding, I was talking with somebody about this earlier. It's not something, Johnny, I think with you, it's not something I've done myself, but there are coding languages and environments specifically for performing and iterating on musical and sound design, like live in front of an audience. Hardware digital synthesizer, it'd be really cool if you could just flash a little system on a chip, put it in a tiny keyboard, shove it in your pocket, take it on the plane with a pair of headphones, and go wild on a 12-hour flight. It sounds like I'm bashing domain-specific languages, but that's not really true. They absolutely have their place, especially this kind of domain. But it's also just fun to make your own languages. So I think it would be nice to make it fun for someone else to make their own music language without having to worry about a lot of the stuff that I had to figure out. It's only fair that I show you what it would be like to use it. This is a very high level, but effectively, you build what's a data structure that's basically an abstract syntax tree. And there's only a few core concepts in this language. There's constant numbers, There are primitive operations like arithmetic, trigonometry, like sinusoid is used a lot in DSP, and a small number of compile time only features for abstraction and metaprogramming like macros and functions and conditional evaluation. Anyway, you take the root node of this tree, you pass it to a compile function, it does a bunch of shit, and then it returns a function pointer, which I'm calling process, and you call this process function in order to process and generate samples. And there's basically two contexts in which you would do this. One is that real-time context, which I described or alluded to earlier. That's performance, that's playing back continuously. And then there's what's called offline, which just means rendering a WAV file to disk or something like that. Let's see what it looks like with a really, really rudimentary example program. This is a high-level walkthrough of what happens. Don't make this program because it's going to sound like garbage, but it's enough to demonstrate the point. So we only have a few constructs here. This is the tree, and in the upper left we have the first two inputs. The upper left is in1. That's basically input. So that can be coming straight from a microphone. It can be the result of a previous processing operation from an external function. And on the right we have a constant number 1000. So those two become the arguments to this built-in multiplication primitive. And the result of that multiplication primitive is then passed as the single argument to a sine function. This sine function is the root node of our program. And this is what's going to be computed continuously for streams and streams of many samples, thousands of times a second. Hryciw is not a Lisp language. In fact, there is not even a concrete syntax, but I think a S expression is kind of a concise way to textually explain that. So anyway, you pass that root node to a compile function. And it starts to do some analysis and evaluation. Constant folding happens here, not in this program, but constant folding happens here. There's functions and macros are totally evaluated out here. Conditional evaluation is all evaluated here, some memoization. And what results is this sort of assembly-like imperative intermediate representation. Also not a concrete syntax. This is just a way to demonstrate this internal format that I'm using right now. Then that is translated to, at least in the just-in-time example, LLVM IR, which then LLVM translates that into machine code, and we get a function pointer, and that gives us back f. That's the process function that we're going to call repeatedly. One possible way that this could look like in another language, there's no canonical way that this would look in Lua, but for example, it could look like this. So that first line, you can see it's a library, it's a module, we're importing or requiring it. And then on the second line, we have that expression, right? And you can already see we're taking advantage of some Lua features like operator overloading. We have that multiply symbol, which turns into the multiplication primitive. I don't know if anybody's familiar with Lua at all, who has used it. Okay, so you know about using like metatables and giving weird behavior. So this ins right here may not be a real table. It might be like a C object. In fact, it would be. That when we index it by 1, we're telling the program, I need one input. So this program has one input. And then there's no like built-in play feature to like start processing audio, but that might be a feature of this binding. Anyway, that's just a really small example. And there's a bajillion things that I didn't go over. I didn't talk about functions much, but they're not the built-in primitives, they're user abstractions that are all flattened out into that single stream of instructions at compile time. Conditional evaluation is the same thing. Certain types of DSPs require state, such as filters that make use of feedback. So the result of one operation then becomes the input to the next one. And so it's a little bit at odds with the purely functional paradigm, but it's actually necessary to implement certain types of DSPs. I didn't show anything about loops. My plan right now is to have no unbounded loops in the resulting program. But some kind of iteration or looping will be necessary for some kinds of DSPs. And rates, I mentioned that this program is essentially conceptually executed for every single sample of the stream. But sometimes you need to operate on a block of samples, like 512 samples, and only once every 512 cycles. And you might need to convert between these rates. That's a much more complicated aspect of it. Polyphony is a musical term, which means playing more than one note at a time. And so, it might be I've made a cool sound, but I want to make it easy to say, I want to play up to 16 of these at a time at most, and each one with its own independent lifetime and amplitude. Bunch more stuff that I'm not going to talk about right now. Okay, so what's going on next? The most important thing for me to do next, or to accomplish next, is to just keep implementing more DSPs. And by this I mean implement more filters for the standard library, compression, which is dynamic control, reverberation for ambience, more complex spectrum synthesis like FM synthesis. If you don't know what these are, it's okay, but FM synthesis, wavetable synthesis, granular synthesis are more advanced techniques for generating interesting sounds. Spectral analysis, which uses the FFT, which is how you get things like auto-tune, pitch follow, and some other kinds of filters. But the important thing is that I'm waiting till I get to these use cases and to implement these use cases in order to know what to add to the core model. And it's not just a matter of pride or having like a small API service. I'm trying it as a way to stick to these guarantees of constant time evaluation as much as I can. We'll see how it goes though. There's a ton of design challenges to solve. I was inspired by Faust's purely functional paradigm because of how well it maps to the DSP domain, but this might be a problem if I want to bind to another language and it just has a hard time working with that paradigm. And if it ends up being an impediment to a disadvantage as a platform and not realistic for applications in general, then that might be a failure of this design and it needs to be rethought. I didn't mention variables, but the core language doesn't have any variables, and so there's no name binding, which means that I guess the idea is that different languages you might want to bind this to might have their own scoping rules, their own lifetime rules, and so the idea was bring your own, but it puts the onus on the developer of their project to figure out how to implement that, so it might be another impediment. And then I mentioned that all of the abstractions and loops and conditional evaluation, everything is just flattened out into one big function, one big stream of instructions, and that's kind of a result of the evaluation model that I just went with to start with, but who knows, maybe for a reasonably sized program, we could write a function that's so long it like destroys the CPU's instruction cache and it actually harms performance. I don't know, I need other people's expertise and to do testing and benchmarking with larger programs to see if that will work or not. I have been writing it with Zig in the latest version, and I think there are potentially some unique possibilities. I know a lot of work has been done to implement native code generation, so like x86-64 backend is like mostly done as kind of an alternative to LLVM. This is not exposed in the standard library, and I don't know if it ever will be, but if it were, I think it would be really cool to be able to remove LLVM as a dependency, generate the smallest possible deliverable executable or package. And Zig has a lot of cool stuff that it just comes with out of the box, like incremental compilation, the global caching system, and hot code reloading, or what is it called? Code swapping, COD swapping. It's called COD swapping. That might actually help Suzu achieve that extremely low latency goal in the just-in-time environment. Oh, look at that! That's the name of the thing. Is this software you can love? It's probably an unfair question. So to even get at it, maybe ask a slightly fairer question, which is, who is this for? Besides just me, is it for programmers or musicians? All right. Okay. Going back to those three layers that I just pulled out of my ass at the beginning: the composition, configuration, and building. The vast majority of music software out there is not the stuff that I showed you, that I walked you through and described. They mostly fulfill the composition and configuration layers of those things, of music making, and that's really what most people need to get done, right? Like they either have a job or they want to express themselves, and that's the layer where most people work. And they let you be expressive, but they don't really let you see what's going on under the hood. Carsten was mentioning like, understanding what's happening at a lower level in the machine. Or tinker with how it works. And so I wanted to know how things worked, and I wanted to make my own, but the rabbit hole always goes deeper, and you have to keep learning more and more things. And we don't want to end up farming goats. I'm going to read you I don't want to call it a poem. This is actually a paraphrasing of an internet post that was circulating around music production forums in the 2000s. So I'll just read it off here. I thought using loops was cheating, so I programmed my own using samples. Then I thought using samples was cheating, so I recorded the sound of real drums. And then I thought sequencing was cheating, so I learned to play the drums live. Then I thought using store-bought drums was cheating, so I built my own. Then I thought buying drum heads was cheating, so I made my own from goat skin. And then I thought that was cheating, so I raised a baby goat to skin it. I still think that's cheating, but I'm not really sure where to go from here. Anyway, I haven't made any music lately, what with all the goat farming. So, thank you, Anonymous. Anyway, I wrote going down a rabbit hole is bad, but I mean, it's not inherently, but the farther you go and the deeper you go, the farther away from your original creative goals you get. And I had this idea the other day about a curiosity safety net, and that's maybe a role that Hryciw could play for somebody. And I think that there are 3 examples of software that already exists that are not advertised as curiosity safety nets, but could be framed as such. The first one that probably everybody here is most familiar with is the LLVM compiler framework. Before that existed, if you wanted to implement a C compiler or if you wanted to design your own programming language, you didn't have to just write the parser and all the analysis logic, but you have 900 and whatever billion different architectures with their own quirks in order to learn how to generate machine code for all those. And LLVM just gives you a single target, which then just takes care of the rest for you. Sort of it becomes the new standard. D3 is a popular JavaScript library for data visualization on the front end. Yeah, nodding. And it's used by like some popular websites like 538. And it's not like a grab bag of different kinds of visualization like pie charts and bar graphs and stuff like that. They don't come with that, but it makes it much easier to make those or any kind of new data visualization that you can think of without having to do everything by hand in JavaScript and probably make a really broken implementation and reinvent the wheel. And one more time for Zig, this actually, on a personal note, Zig was the curiosity safety net for me very explicitly. My original version of Hryciw up until about 2018, I wrote in C, and it's how I taught myself how to program, but I kept hitting these stumbling blocks and frustrations and things that I didn't understand and bugs, and I was this fucking close to designing my own programming language to solve that problem. Some of us have fallen down this hole too. Won't name names, but at the time I was like, wait a minute, I remember seeing this thing about Zig a few years ago that's like a better version of C. I wonder how that's doing. Oh my God, it's exactly what I was trying to do, but way better. And so I never looked back.
Also in the pursuit of music.
And, what's that?
Also in the pursuit of music.
Also in the pursuit of music. That's right. I hear that's true. So anyway, back to this original question. Who is it for? Programmers and musicians. By now, you know the answer. It's actually, well, yeah, it's still just for me, and it might be for both. Anyway, I would say if it's successful, it's for those who like to build their own creative tools, at least in a musical or a sound design context. So for the longest time, before I taught myself to program, I was really afraid to learn software programming at all, even though I wanted to. It was very appealing to me, but I just saw myself as like a creative, as someone that couldn't do it. Like it was totally out of my league, and I had no idea how to get started. But as I got into it, I kind of started to see more of a spectrum instead of an orthogonal pair of categories, the technical and the creative. And programming can be creative, and I've always believed that music can be as technical as you want it to be. And sometimes in the course of either of these practices, you can find yourself sliding back and forth on the spectrum between the technical and the creative. So that's the whole shit. If you want to get in touch with me, that's my website. This is some of the reading material that I would recommend, at least from what I've read. One book I didn't mention, Musemathics, even though it has a terrible name, is an amazing book. And some other DSP software applications if you want to check them out. And if you're interested, if you're in this room, just come up and talk to me. Otherwise, you can find my contact on the website.
Thank you very much, Stevie. So do we have any questions? Okay, I see some hands.
Oh no. Not for you specifically, just, you know. Oh wait, where's he going?
Thank you. So first, congratulations.
Thank you.
Also for the safety net, because I went one step further than you.
I noticed.
I built a 4 VM to basically like have 4 being able to write my DSP operators, and then this had very similar. We need to catch up afterwards.
Yes.
But my goal also was to have it run on STM32
yeah.
platform, like those dev boards. And I was actually going to show this earlier, but yeah, I ended up building my own 4 VM, but going LLVM is much better, obviously, because it generates native code. So I want to know more.
Yeah, likewise, yeah, let's talk.
Thank you.
Next question?
Yes. Have you tried functional reactive programming as a solution to the state problem with the pure functional paradigm?
No, and I'm not familiar with functional reactive. Oh, I've heard the term, but I don't know the first thing about it.
No. There are a few papers by Colonel Elliott that might be interesting, and a presentation by Paul Leo where they generate audio in a similar way. They write Haskell code for DSP, where it's essentially modeling the same circuit you would with the hardware. That might be interesting too.
Yeah, I would check that out. Thank you.
Next question? Okay.
Just out of curiosity, have you also meddled with analog signal processing, like building your own?
I've meddled. So no, I've never built my own circuits for like, you know, analog synthesis. I've just used existing ones, which are obviously better than I could make. But I've long been curious about it. Have you?
No, but I used to live with a guy who uses pure data all day and also builds his own stuff all day. So
Oh man.
I've seen it.
You've seen it, okay.
A lot.
Cool. Pure Data is a really funny example because it's a Max MSP clone that was written by Miller Puckett, who is the author of Max MSP. So he cloned himself and made an open source version of it.
More questions? Okay, I don't see any hand.
I see a hand up front.
Oh, wait, Luke. Oh, okay, sorry.
Poor Luke.
You need to wiggle more. Can I see the wiggle? Thank you.
So where do those older languages come in? You mentioned it was being one of the goals where you can bring your own language. So is it other languages are targeting your language as a...
Yeah. Did my best to try to make this clear, but it didn't quite snap in the end. Are you talking about the 4 existing languages that I walked through to begin with, or like any other language?
No, the way I interpret the title is that other languages can target your new language to create these.
The brief example that I meant to give here was the Lua snippet. So the process you would go through there is, Hryciw right now is a Zig library, but assuming that we have a C interface to it, then you can, and Lua specifically is a great example of this because it's very friendly for extending with C or extending C.
I got it now. You even mentioned it's going to be a library.
Let's just say anything with a C that can create bindings with C is up for grabs.
Got it. Thank you very much.
This is very exciting. What kind of primitive DSP primitives does Hryciw have so far?
Not very many. So I have a few oscillators like sine, like trigonometric functions. I have the basic arithmetic. I don't remember if I've gotten the bit shifting ones done yet, but that's something else you'd want there. Maybe some Boolean operations. That's really as far as I've gotten, and I'm not gonna. I don't know which ones more I'll need to add. There's not a whole lot more. You can do a lot with just trigonometry and arithmetic at the lowest level, and then a lot of other stuff can be abstraction on top of that.
Any more questions? Yeah.
Where's the code?
So I'm not blind to the irony here, talking about what type of license I would want, while the source code is not actually yet available. So yeah, that's a great question. The why not is a great question. Basically, I've been working in the dark on this on and off for a long, long time. And it's always like just about to the point, okay, maybe I can release an early version so people can see it. And putting myself in front of 60 people is really the way that I am trying to stimulate myself to do that and give myself the courage to do it. So I promise it will happen, and you can hold me personally accountable. Just you.
Any more questions? I don't see any hands. Okay, so I have a couple of questions for you, Stevie.
Okay.
First of all, this is going to be an annoying question, but not for you. How much do you think you would want matrix primitives in Z? Would those help you?
Metrics primitives?
Yeah, matrix. Like the ability to have a matrix data type inside Z. Would you want that?
Maybe I don't. When you say metrics, are you? Oh, I'm sorry. Matrix primitives.
Yeah.
Matrix.
Like multi-dimensional.
Okay, matrix operations. The only place where I know that's going to be necessary is in FFT, fast Fourier transform, for the spectral analysis. And that's a thing that even Fausta said has been a really challenging problem for them, and I want to be like, oh, I could do that, even though I barely understand the math. That's one place where it would come in handy, but I assume as an optimization. There's a lot of this stuff is just going to be made faster by vectorizing the code and stuff like that, and I assume that this would just be a way to optimize something that could otherwise be done with more instructions.
Okay, thank you. Second question: if you had to recommend a musical instrument for somebody to start learning how to play, to do music,
yeah.
Which musical instrument would you recommend?
Oh, easy, nose flute. There's no buttons on it. You just put it on your face and you blow through your nose, and then you change the shape of your mouth. If not that, then piano. Yeah, 100% piano.
Okay, thank you very much. Please give it up for Steve.
I don't know why I was clapping for myself.